Okay, what if I told you there's one single material that's inside those giant wind turbines powering our cities that makes up the hull of a boat out on the ocean and is at the very heart of the smartphone you're probably holding right now? I mean, it is a true hidden giant of our modern world, and today we're going to put it right under the microscope.
Yeah, it's the stuff that makes up these massive wind turbine blades. I mean, some of them stretch longer than a football field. And you gotta think, they have to be unbelievably strong, but also surprisingly light. They have to put up with decades of just relentless weather to catch that wind and, help power all of our lives.
And it's also right here in the sleek, super durable hull of this boat. This is the stuff that lets it fight back against the corrosive power of salt water, year in and year out. It handles impacts and provides the backbone for, well, pretty much everything, from a tiny little kayak to a gigantic yacht. And, look no further than the device you're probably watching this on right now. This material is the fundamental base for the printed circuit boards inside. It's that non-conductive backbone that holds all that incredibly complex electronics together. Without it, your phone just wouldn't work.
So you've got energy, transportation, technology. What is this stuff? This super material that's absolutely everywhere but somehow practically invisible. All right, let's pull back the curtain and really dig into the science behind one of the most important and seriously overlooked materials of our time.
Okay, so the material is fiberglass, but, and this is a big but, the name's a little misleading. See, it's not just glass. The real genius here is that it's a composite. And what that means is it's a material made by mixing two totally different things to create something way better than either one could ever be on its own. Right, so the secret sauce is all in the combination. You take something ancient, glass, and you draw it out into these incredibly fine, almost hair-like fibers. Then, and here's the key, you lock those fibers into place with a modern polymer resin. That is where the magic happens. Just think about the teamwork here for a second. On one hand, you have the glass fibers. They're immensely strong, but they're also pretty brittle. They can snap. Then, on the other hand, you've got the resin, which is easy to mold, but not all that strong by itself. But when you put them together, the resin acts like a shield, protecting the fibers and spreading out any stress across all of them. It's literally the best of both worlds. And that is exactly why we see it in everything from boats to circuit boards. I mean, this combination of properties is just so rare. It's stronger than a lot of metals, but it's lightweight. It doesn't rust or corrode. It's a fantastic electrical insulator. And on top of all that, it's relatively cheap to make. It's pretty much a materials engineer's dream come true.
So the big question is, how do you get from something as simple as sand to a high-tech boat hull? Well, the process is a pretty remarkable journey, a real feat of industrial engineering. And, even though fiberglass feels super modern, its roots actually go back more than a century. But the real game changer, the big breakthrough, happened back in the 1930s and 40s. That's when two crucial technologies finally came together: the skill to draw molten glass into these ultra-thin fibers and the invention of synthetic resins to hold them all together. Okay, so the whole process kicks off with some serious heat. We're talking over 1,400 degrees Celsius. That's more than 2,500 degrees Fahrenheit. It's hot enough that everyday stuff like silica sand and limestone just melt down into this glowing, molten liquid glass. From there, that molten glass gets pulled through thousands of teeny tiny nozzles, and that's what creates these filaments that are actually thinner than a human hair. These tiny strands get coated with a special chemical to protect them, and then they're bundled together. It's only then that they're finally mixed with the resin and molded into whatever they're destined to become. A surfboard, a car part, a structural beam, you name it. But here's the twist. The very thing that makes fiberglass so amazing, that incredible durability, its refusal to break down, that's also its biggest problem. Its greatest strength becomes its greatest weakness when it's time to throw it away. I mean, think about it. We designed a material to last for decades, sometimes even longer. And that means it is incredibly difficult to break down. So this leaves us with a huge, massive problem. What on earth do we do with millions and millions of tons of this stuff when its job is done? And the situation right now, well, it's pretty stark. The vast, overwhelming majority, we're talking about 85% of all that used fiberglass, from old boats, car parts, those giant wind turbine blades, it just ends up in a landfill. A tiny, tiny fraction ever gets reused or recycled. So why is that?
Well, the science behind it really comes down to the resin. See, most fiberglass uses something called a thermoset resin. Now, this is totally different from a thermoplastic, like, say, a plastic milk jug that you can melt down and reshape. A thermoset goes through this chemical reaction that's completely irreversible. Once it's set or cured, it is locked into that shape for good, forever. But hey, the story doesn't just end in a landfill. That exact problem, its permanence, is actually sparking a huge wave of creativity and innovation. Engineers and designers are now figuring out how to give this incredible material a second life. So instead of trying to smash this stuff up or melt it down, one really clever approach is to not break it down at all. That's right. Engineers are finding brilliant ways to repurpose entire fiberglass parts. Those huge wind turbine blades I mentioned, they're literally being sliced up and turned into things like pedestrian bridges, bus shelters, and even playground equipment. How cool is that? And it's not just about creative reuse. Scientists are also pushing the boundaries of actual recycling. They're finding better ways to shred it up to use as filler or to carefully burn off the resin to get the glass fibers back. But the real holy grail, the ultimate goal, is to develop totally new kinds of resins that are recyclable right from the get-go. That would create a truly circular economy for fiberglass. So, the big takeaway here is that the story of fiberglass has this crucial new chapter being written right now. The focus has totally shifted to sustainability, and it forces us to ask a really important question. How do we design a forever material for a future that has to be sustainable? How do you make something that's tough enough for its first life, but is also designed for a second or even a third? Answering that question is what will make sure this hidden material can keep on shaping our world, but responsibly.